Hello everyone, very good morning and welcome to BYJU'S Exam Prep, most comprehensive app for all exams. How are you guys? Now, we are going to discuss very important topic for what BARC and HAL exam, that is what MOSFET and your favorite operational amplifier, right? So ready guys? And this is a very important topic, BARC and HAL 2022 analog part 2. In analog part 1 already we have discussed BJT and diode circuit. So first of all inform me that sound quality, picture quality, everything is fine. Yes everyone, please inform me that sound quality, picture quality, everything is fine. Very good morning Suvajit Mitra Singh Bhavna, very good morning. तो एक बार मुझे inform कर दीजिएगा जब everything is fine now. Yes, now this is a BARC and HAL 2022 analog part 2. Okay. So which topics are important for from analog? Already I have given you the diode circuit, right? Thank you Ritik. Now which topics are important? Diode circuits. Diode circuit means what? Rectifier, clipper, clamper, voltage doubler, voltage regulator, right? And after that biasing of BJT. Then what? Biasing of, after biasing of BJT, low and high frequency analysis of what? BJT. Multi-stage amplifier, okay, feedback amplifier, oscillators, and then what? MOSFET and operational amplifier. So in MOSFET and operational amplifier, which topics are important, and some topics we will discuss here. So please stay tuned with me. Now that is what, this is my introduction. Myself Sanjay Rathi, 20 plus years of teaching experience in the field of competitive exams like ESE, GATE and PSU. Okay, so zara ek bar please like the session and share the link of this session. Okay, then here this is my introduction. I have qualified and selected for engineering services exam. These are my ranks: AIR 16 in ESE 2005 and AIR 21 in ESE 2008, and I have mentored more than 1 lakh students for these competitive exams. Okay guys, now very good morning Chinmay Rai, how are you? कैसी चल रही है आप लोगों की? What about your preparation for BARC and HAL and other competitive exams? Going well, or are you waiting for result of GATE 2022? Okay, now how to start preparation for what? GATE 23 and 24 by Rakesh Talreja sir and Asutosh Saxena sir. Strategy, right time to start, tips and tricks, each and everything about GATE 2023 and what? 2024 at 5 PM today, 5th March. Okay, so please join that session. Now my dear friends, that is first question on screen. First question on screen. Very good morning, how are you? Tulya Karunkar. Then the input resistance of the circuit shown in the figure assuming an ideal operational amplifier. When we are assuming the ideal operational amplifier, sometimes we have to, right? Okay, Ravi Teja, how are you? So everything is fine now. So picture quality is fine, sound quality is fine. Priya Mohan, very good morning. Riki, that is one question. The input resistance of the circuit shown in the figure assuming an ideal operational amplifier is. Assuming an ideal operational amplifier. What will be the answer for this question? Okay, take it zara. Now here we are connecting R. This is the 3R, this is the 2R, and in number of questions we have to find the input resistance. The option is R by 3, 2R by 3, R and 4R by 3. Okay, yes please. Now if you want to calculate, we have two ways to solve that. By one way is what? Simple V in by I in, and second way is by using what? Miller's theorem. Okay, we can use Miller's theorem also. So what is the answer for this question? Now first watch this diagram. Here we are having the R, this is the 3R. Now if input resistance is required, R in is equal to what? V in by I in. So that is the general formula, right? Surjit Ravidas have given the answer R by 3. Now we will check. Okay, now this is R, this is the 3R, this is the 2R. For any type of diagram, if you want the input resistance, simply that is the V, this is the I in, this is the current. Now it is an ideal operational amplifier and there is a negative feedback, and that's why virtual short concept is valid. So Vp is 0 and that's why Vn, negative terminal voltage, is also 0. This is also called virtual ground process, VGP. Voltage at this point is what? 0. Now this I in is divided into two parts, like this is the I1 and this is what? I2. This is I1 and that is I2. So we can write I in is equal to what? I1 plus I2. Now we have to find the I1 plus I2 in terms of what? V in, so that we can cancel it. Now this point is V in, this point is 0, then directly we can find the I1. I1 is equal to V in minus 0 divided by R. So this will become V in by R first. So this is the equation number 1, 2, this is the equation number 3. Okay. Now second thing, what is the voltage at this point? 0. Now you can apply the KCL at this point. 0 minus V in by R plus 0 minus V naught by 3R. We are simply applying the KCL at this point. 0 minus V in by R, 0 minus V naught by 3R. Now this R is cancelled out. This will become V naught by 3, and finally you will get the V naught is equal to minus 3 V in. Please solve this. That is the, this is the V naught in terms of what? V in. Why we are solving this? Simply to get the I2 in terms of V in. Now we can write the I2 in terms of V in. What is the I2? V in minus V naught divided by what? 2R. V in minus minus, it will become 3V in divided by 2R, and that is 2V in by R. Now we have the I2 in terms of V in, we have the I1 in terms of V in, and that's why we can write I in is equal to I1. What is the I1? V in by R. Plus, what is the I2? 2V in by R. And this will become 3V in by R. Now this is the value of I in. So what is the V in by I in? That is called input resistance is equal to R by what? 3. This is the answer, R by 3. So new students, in any questions, simple way to find the input resistance is the value of that battery and the current given by that battery. Yes, Chinmay Rao, your answer is correct. Kanu Kumar, your answer is correct. Subhajita, your answer is option A, R. Right? Yeah, this is the option. In previous class, I think I have given one question, that is the wrong option, but the explanation is correct. This is the R by 3. R by 3. Now second one, we can also apply the Miller's theorem here. We can also apply in this type of questions, we can apply the Miller's theorem also. What is the Miller's theorem? Right? How we can apply the Miller's theorem? Very simple. For example, that is the one way to find V in, that is the value and current given by that battery. Second, if we want to apply the Miller's theorem means what? This is the Miller's theorem. Suppose we are having one resistor here. Then this is the V1, this is the V2. If we are having the value K, V2 by V1, then we can break this resistor into two parts. One, this is the R. You can get direct question from this theorem. Here another R. This is called R1 and that is called R2. Now simply this R is break into what? Two parts, R1 and R2, and this R1 is given by R upon what? 1 minus K. R upon 1 minus K, and this R2 is given by KR upon K minus 1. KR upon K minus 1. That is called what? Miller's theorem. Okay, once you will get the Miller's theorem, give me 1 minute. Yes. Once you will get the Miller's theorem, now you can break this register like, right? We have first of all apply the KCL at this point. KCL, this is 0, this is 0. Already we have applied the KCL and you will get the relation that V0 is equal to V0 by Vi is equal to -3. Yes or no? V0 and Vi is equal to -3. Already we have taken. This is the KCL 0 minus Vin by R, 0 minus V0 by 3R, and there is no current inside the operational amplifier, and that's why already we have find that V0 by Vin is equal to -3. Once this is known, K, this is the K. Now you can apply what? Miller's theorem. Now you can apply the Miller's theorem. Miller's theorem means what? Simply break this register. Now what is the register here? R. This register is what? 3R. And this is R. Break this register 2R. Here this will become 2R upon 1 minus K. What is the K? Already we have solved -3. So -3 minus -3, it will become +4. So 2R by 4, this is become R by 2. K is equal to -3. Already we have proved this. Right? Now, this is the Vin. This is 0. Up to this point, always remember, up to this point, the input resistance is R. Up to this point, the input resistor is R, and now this R by 2 is in parallel. So what is the R in? R parallel with R by 2. Now you can solve this and you will get the answer R by 3. You will get the answer R by 3. So this is another way to find what? Another way to find the input resistance, that is by using the Miller's theorem. Okay. So please tell me, in case of non-inverting operational amplifier, what is the input resistance? In case of inverting and non-inverting operational amplifier, what is the input resistance? Everyone, please tell me. This is the case under ideal condition. This is the 10 kilo ohm, this is the 2 kilo ohm. This is the way. What is the input resistance? In comments box, give me the comments. Yes, please, everyone. What is the input resistance in this case? And what is the input resistance in this case? Under ideal condition. क्या होगा भाई? सब के सब कमेंट्स बॉक्स में झड़ी लगा दो यार, आप तो एकदम एग्जाम पास में है. दिस इज अ वेरी वेरी बेसिक एंड सिंपल क्वेश्चन. यस, और जरा यार एक बार प्लीज शेयर द लिंक ऑफ दिस सेशन so that student will join the session. Okay. Infinite in second case, and in first case always remember, because this is a virtual short, this is 0, this is 0. What is the resistance? What is the seen by V in? That is called R in. So R in is nothing but V in by I in, and that is nothing but R1, that is 2 kilo ohm. This is normally represented by R1, this is represented by RF. For this case it is the 2 kilo ohm, and for this case it is infinite. Because we are watching here, what is the current given by the battery? 0. So Vs by 0, that is the resistor seen by this voltage source, is what? Infinity in case of non-inverting operational amplifier. Bilkul Asutosh Samal, your answer is correct. Definitely it is, answer is correct. 2K and what? Infinite. बहुत बढ़िया. Second, now tell me, what is the feedback mechanism in non-inverting operational amplifier? In non-inverting operational amplifier, what is the feedback mechanism? Voltage series, voltage shunt, current series or current shunt? Tell me. Current series. There are 4 types of feedback mechanism There are four types of feedback mechanism: voltage series, voltage shunt, current series, current shunt. Then what will be the feedback mechanism in case of नॉन इन्वर्टिंग ऑपरेशनल एम्पलीफायर? क्या होना चाहिए भाई? यस प्लीज बताइए मुझे जरा. और देखिए, इफ यू वांट देन वी विल अरेंज एक्स्ट्रा सेशन फॉर यू, बट वी वांट प्रॉपर रिस्पॉन्स फ्रॉम योर साइड, एंड दिस एग्जाम इज अ वेरी वेरी इंपॉर्टेंट एग्जाम एंड इट इज अ गोल्डन अपॉर्चुनिटी फॉर यू, राइट? Ritik, voltage, Surjit is giving the answer, voltage series, and Saud Akhtar is giving. I am talking about the non-inverting operational amplifier. I am talking about the non-inverting. So, my dear friends, always remember, in case of non-inverting operational amplifier, I am talking about the non-inverting. What is the answer? Ritik Gunjan. Voltage shunt. Surjit is giving the answer, voltage series, and Saudi Akhtar giving the Neha voltage shunt. Racha, Bhavani, देखो नेहा, in case of non-inverting operational amplifier, the feedback mechanism is voltage series feedback. Here it is a voltage series feedback. Option A is correct. Option A is correct, right? Always remember, in this case, voltage series feedback, right? Or in case of inverting operational amplifier, this is a voltage shunt feedback. The B option is correct. Voltage shunt feedback, right? Voltage shunt feedback. So inverting voltage shunt, non-inverting voltage series feedback. And remember that in voltage shunt feedback, input resistance decreases, and that's why the input resistance is very small. In voltage shunt feedback, input resistance decreases, output resistance also decreases, and that's why this is the input resistance is very very small. Or in this case, always remember, input resistance increases because of this voltage series, output resistance decreases. So ideally we are calculating infinite, otherwise the input resistance is very very high in case of non-inverting operational amplifier. Next question, बताइए जरा, ये हो गया इसके बारे में. Now next one, determine the output voltage V naught for the below circuit where Vin is equal to sine of 100 pi t. We are giving the input sine of 100 pi t. Okay, this is the sine of 100 pi t. Output voltage V naught. So what is the output voltage? This is given as 100 ohm. This is the 1 picofarad. This is again 100 ohm. 1 picofarad. Right, this is the 100 ohm, that is the 100 ohm. Now, answer A, 2 sine of 100 pi t. Answer B, sine of 100 pi t. Answer C, sine of 200 pi t. Answer C, 0.5 sine of 100 pi t. What will be the answer? Very very simple question. The R, this is R, 100 ohm. This is 1 picofarad. 100 ohm, 1 picofarad. These values are remain equal values. Yes, please. What is the name of the first figure, everyone? What is the name of the first figure? We are connecting here R, here we are connecting the C to whether it is an integrator or differentiator. This is the integrator and this is the differentiator. The first diagram, watch this diagram, integrator or differentiator. Second diagram, integrator or differentiator. So according to ECE Karunkar, first diagram is what? Ritik Gunjan, first diagram is what? Integrator. Yes, definitely it is integrator, right? Second diagram is a differentiator. Second one is what? Differentiator, from this point to this point. Integrator and what? Differentiator. Okay, integrator and then what? Differentiator. Yes. So once the signal will we will integrate the signal and then it is differentiated by the signal, then what will be the output? Second op amp of the resistance 100 ohm, 100. This is 100. 100 ohm. According to the question, give me the answer. That is 100, that is 100, 1 picofarad, 1 picofarad, everything is same. Tell me. Right. It will remain same, better, definitely. Because in integrator, always remember, in integrator, this is the R, This is the C. If there is no initial voltage, always the output of the integrator 1 by RC. This is RC with negative sign. Integration of VI dt. 1 by RC integration of VI dt. And what is the output of the second? V0 is equal to minus RC d by dt of what? D by dt of V01. D by dt of V01. This differentiator is cancelled out by integration, and RC and minus is cancelled out, and we are getting the same output. We are getting the same output, that is what? Sine of 100 pi t. Now I'm going to ask some conceptual question. Please give me the answer for this question. This is the answer. This is a very simple question B. Now watch this diagram, first diagram. Watch this diagram. This is an integrator, right? This is the integrator. This is the minus, this is the plus. Here we are connecting C. Here we are connecting C. This is the 2 microfarad. This is the 2 microfarad. This is the operational amplifier. And the gain of the operational amplifier magnitude is 10 to the power 6. This is the open loop gain of the operational amplifier. It is not infinite. It is not infinite. The open loop operational amplifier is 10 to the power 6. Then what is the value of input capacitance? Everyone, what is the value of input capacitance here? That is the question, because this is related to what? Integrator. Why we are connecting the capacitor here? Why we are connecting the capacitor here? And why we are connecting the resistor here in case of differentiator? That is a very logical question. What will be the value of capacitor at this point? Because here we are connecting the 2 microfarad capacitor, then what will be the value, effective value of the capacitor at this point? Yes, क्या होगा भाई? Surjit is giving the answer 2F. EC Karunkar is giving the answer 2F, 2 farad. Any other student? Now watch this diagram. This is called what? This is called capacitor multiplier. This is called what? Capacitor multiplier. So simply break this capacitor by using Miller's theorem. Again by using Miller's theorem. Now we can break this. Simply watch this. When this capacitor, this is the minus, here we are getting one capacitor, and here we are getting the another capacitor. Please leave it. And this capacitor in input side, it is given by C, that is the value C, into what? 1 minus AV. Now here we are taking the VI, this is the VI and this is the V0. Here AV is equal to AV is equal to V0 by VI. This is nothing but open loop gain. And when we are taking the Vn minus Vp, when we are taking the input of Vn minus Vp, always remember you have to take AV is equal to what? Minus 10 to the power 6. Always remember, when we are taking Vi is equal to negative terminal minus positive terminal, take open loop gain of the operational amplifier minus 10 to the power 6. And when you will take Vi is equal to Vp minus Vn, then AV is equal to AOL is equal to what? 10 to the power 6. Here mod is given, so you have to take minus. Then the value of the capacitor 1 minus AV. C input is equal to C1 minus AV, that is nothing but C, this is the 2 microfarad. 1 minus of minus 10 to the power 6, 1 is negligible, neglected, and it will become 2 farad. My dear friends, normally high value of capacitor is not possible, and that's why we are using the operational amplifier and we are getting the high input capacitance. High input capacitance, that is of value 2 farad. Okay, so this is called capacitor multiplier. This diagram is nothing but capacitor multiplier. capacitor multiplier, right? And similarly, in this case, we can reduce the value of R. Already we have solved one question. You can use the Miller's theorem and the value of R will decrease. Why? Because Miller's theorem, R, actual R is what? R upon 1 minus AV. In case of capacitor, it is multiplied, but in case of resistor, it is divided. We can say it is a resistor divider circuit. We can reduce the value of the resistor by using this circuit. We can reduce the value of the resistor by using this circuit, because small value of resistor is not possible. Small value of resistor is practically not possible. You can break like this. R upon what? 1 minus AV. That is divided by 10 to the power 6. Divided by 10 to the power 6. If suppose you want the resistor in milliohm range, practically not possible. Milliohm range, connect here 1 kilo ohm resistor. 1 kilo divided by 10 to the power 6, it will become 1 milliohm. 1 milliohm resistor, because it is in kilo ohm. That is possible by using this circuit, resistor divider circuit. Resistor divider circuit. I think this concept is clear to you everyone. तो भाई जरा अब आगे आ जाओ. ये तो एक हो गया टॉपिक. अब आते हैं, ये देखो, ये क्वेश्चन है. बताइए व्हाट विल बी द आंसर फॉर दिस पर्टिकुलर क्वेश्चन, राइट? ये तो मैं आपको बस हिंट करूंगा और एंड ट्राई टू सॉल्व दिस क्वेश्चन, राइट? डिटरमाइन द क्लोज लूप वोल्टेज गेन ऑफ द सर्किट शोन इन द फिगर एज्यूमिंग एन आइडियल ऑपरेशनल एम्पलीफायर. Assuming an ideal operational amplifier. This is the R, this is the R, that is R, this is R, this is R. Everything is R, right? And this is also R, minus negative. This is the V in, that is the V out. You have to find the V out by V in. V out by V in. What will be the value? Okay. So देखिए, some students want to apply what, sir, we can apply the star delta conversion. Yes, you can. Star delta conversion, or this is the star. You can convert it into a delta, and then again you have to apply this, right? Or directly you can apply what, KCL or KVL. Yes, that is also possible. Okay then. And this is a resistor R a group, and then बताइए जरा क्या होगा आंसर? सुरजीत सर, इज इट क्रिएटेड एनी डिस्पर्सन एज इनपुट साइड टेक्स हाई टाइम टू चेंज एंड लेस इन लोड साइड? मीन्स you want to say that input side, this is the time constant is high, and output side time constant is low. But ultimately for any circuit, we want what, when we are giving the input and we want the response at the output. If suppose one portion has high time constant and one portion has low time constant, then definitely which will decide, the high time constant will decide the delay time of the circuit, right? Suppose we are having a 2 time constant for any circuit, then high time constant will decide the delay time of the circuit, right? So that is the logic. So you are giving the answer that minus, because it is an inverting operational amplifier, so there will be a negative sign. There will be a negative sign, right? Okay. So what will be the answer? R, everywhere R, right? One very simple way to solve this question is, right, 1 minute. This is R, that is R. Now one, two, three, four, 1, 2, 3, 4, 5. This is the question. Okay, what is the answer? Option C, -8. Yes, 1 plus Rf by this formula. Chinmay, you are using 1 plus Rf by R, and you are calculating what? Rf by using which method? By using which method? Simply, you are solving this register, right? Okay, you are solving the equivalent register of this portion. Yes, that is the way. Second way, always remember that this is the virtual ground, this is the virtual ground. Your answer is correct, just I am giving you the hint. For new students, if you are always remember there is a virtual short concept. Vp is equal to Vn is equal to 0 first. Now let this voltage is V1, let this voltage is V2, and this is the final V0. By applying the KVL, you will get the answer. First of all, V1 in terms of V in, then second and V2 in terms of V1, and third is what? V0 in terms of what? V2. Second method, watch this. These two are in parallel. This is the ground, this is the ground. This is the ground, this is the ground. So these two are in parallel. So what is the R equivalent, everyone? This is virtual ground, this is physical ground, no problem. R. This is the R parallel with R, right? Now R by 2, right? R parallel with R by 2, and plus add this R, then this R, right? And finally you can divide the current here. This is the current. What will be the I1 here, then what is the I2 here, then what is the I3 here, and finally what is the I4. Okay, in terms of I, and finally this I4 will pass through this register, and you can get the value of I4. I4 is nothing but the 0 minus V in by R. 0 minus V in by R. This is nothing but I4. So now we are getting the I4 in terms of what? V in. This is the first equation. Now how? Because current enter into the operational amplifier is 0, that's why this complete current will pass through what? I4. Complete current will pass through I4. Now how we can use the current division rule? How we can use the, your answer is, yes, answer is -8, no problem. We can use this current division rule because this is R, that is R. Again these two R register are equal, and that's why the equal current will divide it here, but you have to find the value. You have to find the actual, what is the resistance. This is not the ladder network R to R, R to R. This is R, 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 R. First of all, find this 2 R by 2. It is in series 3 by 2 R, and that is the R, and so on. Divide like this and you will get the answer. You can use this method. One very easy question I am just giving because it will become lengthy. Now, watch this question. We have similar type of question here. That is the value. This is the V0. Okay. Similarly, this is the question. Similarly, this one is the question. Right now, watch this question. This is ground, that is ground. Let this current is I. This current is moving here. Okay. This current is, simply use the current division rule. What is the current division rule? What is the current here? Let I1. So what is the I1 is equal to I divided by, watch this, 10 plus 1 into 1. That will become I by 11. So this current is nothing but I by 11. Now I by 11 will pass through this I by 11, that is the 0. Now you can write 0 minus Vs by 1. 0 minus Vs by 1 is equal to I by 11. And that's why we can say I is equal to minus 11 Vs. Minus 11 Vs. Okay. Now from this point to this point, write down the KVL and you will get the V0 also. V0 is nothing but 10I plus 10 into I by 11. And what is this? 110 plus 10 I by 11. This is the V0. And V0 will become 120 I by 11. Now you have in, you have right? Vs, what is the Vs here? Vs is nothing but V in minus I by 11, divide it, 11 cancel, I cancel. What is the answer? What is the answer for this question? V naught by Vi is equal to minus 120. V naught by Vi is equal to what? Minus 120. Simply current division rule. I am using the simple current division rule here. This is the I here. What is the current here? I1. I am using the current division rule. Same current will pass through this. I am getting the Vs in terms of what? I, and V naught in terms of what? I. V naught by Vi, you will get the gain, that is what? Minus 120. No need to apply the star to delta conversion, right? No need to apply the KCL, simply by using the current division rule. This is the another method to solve this question. Normally we are star to delta conversion, or simply what we are using, like this is the Vx and we are applying, this is the 0, we are applying the KCL here, we are applying the KCL here, and we are getting the answer V naught by Vs. I think that is clear to you, right? Rakesh Sahu. Recorded lectures will be available, but the PDF will be available on what? My Telegram channel, that is Electronics by Sanjay Rathi. Okay, so please everyone join that channel. Now I'm sending the link. Please give me the answer for this question. This is a very important diagram. This is called differential amplifier. I'm giving the value. This is the 2.2 kilo ohm. This is the 1.5 kilo ohm, 3.3 kilo ohm, and this is the 1 kilo ohm. This is the 1 kilo ohm. Here it is a 2.5 volt V1 on negative terminal. Here it is a 1 volt in positive terminal. What will be the output for this? V1 on inverting terminal 2.5, V2 on non-inverting terminal is 1 volt. The output voltage V0 of the circuit shown in the figure. What will be the output for this question? क्या होगा भाई? Avinash, what is your queries? Please दो तो अरे comments ऊपर नीचे हो गए. Please give me the again please post your query. क्या है भाई? कोई भी आप गुस्सा मत होइए बस. और आप यार जरा लेकिन एक बार मैं आपको अपना टेलीग्राम चैनल का लिंक सेंड कर दूं, जब तक मुझे बता दीजिए व्हाट इज द आंसर फॉर दिस पर्टिकुलर क्वेश्चन. आई थिंक सबने ज्वाइन कर लिया होगा. अगर आपने नहीं किया है तो प्लीज ज्वाइन my Telegram channel, that is Electronics by Sanjay Rathi. Okay, please join this channel so that PDF will be available to you. Okay, already number of contents available for you from network, from analog and other subject, right? हाँ, आपको आप you can please join that link, that Telegram channel. You will get the link of all those sessions, चाहे network or other subject. Okay, right. D option minus 4.5 volt. Okay, चलिए चेक करते हैं. Always remember, this is a differential amplifier. This is the normally we are writing this RF. This is R1, this is R3, and this is R2. Okay, if RF by R1 is equal to R3 by R2, first of all always check this. RF by R1 2.2, R3 by R2 not equal. If this is equal, suppose if this is equal, then CMRR, what is the value of the CMRR? What is the value of the AC? Fill in the blanks, give me the answer respectively. What is the value of CMRR, common mode rejection ratio, and what is the value of the AC? If that is the case, the output will become simply minus RF by R1, plus RF by R1, plus RF by R1, non-inverting terminal voltage minus inverting terminal voltage. So in this case it will become V2 minus V1. But plus RF by R1, V2 by minus V1, for this answer this condition should be satisfied. This condition should be satisfied. But in this case that condition is not satisfied. Previous question someone has to told find using the 1 plus RF by RS using this, but how can we find RF equivalent looking from the inverting terminal as Okay, V naught तो zero नहीं है, V naught is not zero भाई, right? But you can if suppose we are taking the Vi is equal to 0, then Surjit, what should be the input? Suppose we are taking the Vi is equal to 0, then what will be the output? In that case, we can calculate. Okay. Watch this. V naught is equal to Rf by R1 E2 minus V1. Now please watch. और क्या पूछना चाहते हो सुरजीत? पूछना जरा उसे. Yes. In this case, the answer is what? D minus 4.5. Second, if this condition is satisfied, Rf by R1 is equal to R3 by R2, then CMRR will become infinite, AC will become what? 0. Third thing, if this is the not matched, if Rf by R1 is not equal to R3 by R2, then directly write superposition theorem. First of all, find the voltage at this point, R3 by R2 plus, please remember this formula because it is very, very important one, R2 plus R3 into 1 plus Rf by R1 non-inverting terminal voltage minus Rf by R1 into inverting terminal voltage. So what is the R3? R3 is 1.5 divided by 3.3 plus 1.5 into 1 plus Rf by R1, 1 plus Rf by 2.2 divided by 1, right? Minus Rf by R1. What is the minus Rf by R1? 2.2 divided by 1 into 1. And that is the formula. That is the formula for this question. Okay. So you can calculate this value by using this one. Right. So what is the answer you are getting? Minus 4.5, I think. So you can, everyone, you can calculate this formula. So always remember, if this condition is not met, right, simply not met this condition, then simply write down the answer R3 by R2 plus R3 into V2 into 1 plus Rf by R1. This is called non-inverting terminal output minus Rf by R1 into what? Inverting terminal voltage. That is the answer, complete answer for this question. Calculate it and check your answer. V2 is there. ये तो this is the V2. हाँ, यहाँ पे V2 multiply करो ना. What is the value of the V2 here? A numerical data you can put. What is the V2? V2 is the 1 volt minus 2.2 into V1. What is the V1? 2.5. This is the 1 volt and 2.5. Simple answer. Yes, CMRR is infinite and AC is what? 0. And AD is what? Rf by R1. This is called AD. Next question. So this is a differential amplifier. Now, what is the answer for this question? What will be the answer for this question? Dekho, a property, operational amplifier property is what? Inverting, non-inverting, integrator, differentiator. Already we have solved question from differentiator, integrator. Already we have solved question from what? Differential amplifier. Then next property is what? Slew rate. What is the slew rate? A sinusoidal input which can be reproduced in an operational amplifier, which can be reproduced in an operational amplifier without any distortion, having slew rate of 10 pi volt per microsecond. This is the unit of the slew rate. 10 pi volt per microsecond and 5 volt peak output amplitude. 5 volt peak output amplitude. जो अभी आपका आउटपुट का एम्पलीट्यूड आने वाला है, that is the 5 volt. Right? Has the maximum frequency of, what will be the maximum frequency of? Yes, you are giving the answer option B. Okay, that is 1 mega. Sir, what about the time constant of the differentiator and integrator? Okay, Raji, time constant of the integrator should be high as compared to what time period of the signal, and time constant of the differentiator should be low. Time constant of the differentiator should be low as compared to time period of the signal. Okay, so simply just after this question I will give the answer for this question. Okay, so what is the answer? Slew rate. Slew rate is the maximum rate of change of output voltage. dV by dt maximum. This is the slew rate. Okay, maximum rate of change of output voltage. Now what is the asked here? The output amplitude has the maximum frequency of, right? Maximum frequency of. Slew rate is given as 10 volt per microsecond. 10 pi. This is the 10 pi volt per microsecond. Now, if we are having the output, what is the peak value of the sinusoidal input which can be reproduced? So again, the output will be also sinusoidal. 5 volt peak output amplitude. So 5 volt is the peak. Again, we are giving the sinusoidal, let it is the sinusoidal. Now, what is the rate of change of this? dV naught by dt is equal to nothing but, what is the differentiation? 5 omega cos of omega t. Right? Check my differentiation. Now, this is the maximum. When it will be the maximum? Then when the cos omega t is equal to 1. Then dV naught by dt is maximum. What is the maximum value? 5 omega. Now, this is the nothing but maximum rate of change of that. Okay, so this will become 10 pi into 10 to the power 6. This is in microsecond. This will become 10 pi into 10 to the power 6. 10 pi into 10 raised to power 6 volt per second. First of all, convert this slew rate into this value. 10 pi into 10 raised to power 6 volt per second. So this is the slew rate. 5 into 2 into pi into f, because the frequency is required in hertz. Now this 10 cancel, pi cancel. What is the answer? 1 megahertz. 1 megahertz. Okay, so this is the answer for your question. 1 megahertz. So always remember, slew rate is given by dV naught by dt max, right? Okay. अब क्या है क्वेश्चन? हाँ, आपने जो क्वेश्चन पूछा ध्यान दीजिएगा. We are designing, this is the please tell me which type of filter it is, high pass or low pass? Which type of filter, everyone? This is the part of analog. Which type of filter here? Okay. First one is the low pass filter, second one is the high pass filter. Now we are designing नेहा महाजन, बाकी स्टूडेंट्स प्लीज इसका जवाब दीजिए. ऑलरेडी इट इज स्टार्टेड, so otherwise I have to collect information. Now this is a low pass filter, and if RC, always remember, we can't say what about this line, this is a larger or smaller, everyone. We can't say whether this line is larger or smaller. Okay, this is clear to you? We can't say what about this line, it is a larger one or a smaller one. It is a comparative term, and that's why RC, that is called time constant of the circuit. If this time constant of the circuit is very greater than what time period of the signal, suppose some signal is entering here and whose time period is what t, if this is very large, then it behaves like what? Integrator. Then it behaves like integrator. Remember this. And this is the RC. This is the RC. This is the RC time constant. This is the high pass filter. And when RC is very smaller than what t, time period of the signal, then it acts as what? Differentiator. Very simple logic. In this case, we have to reduce the time constant. We have to reduce the time constant. Yes. In previous question, the answer was B. This is the answer, B for Bombay. Now that is the slew rate, and this is the concept. You are asking that what about the time constant? RC should be high and RC should be low, and that's why we are using this circuit. We want to increase the value of the C. That's why we are using the capacitor multiplier. Or in this case, we want to reduce the value of R. That's why we are using the resistor divider circuit. And that is the logic. This is the resistor divider circuit because we want to reduce the value of resistor. Here we want to increase the value of the capacitor so that we can get the high time constant, RC. This is called integrator, and that is called what? Differentiator. Okay? Okay, next question. If RC is very less than the tilting where Surjit, RC is very, in which case you are going to get the tilt. Tilt की problem ना इसमें आती है, right? No, that in that case, sorry. In that case, tilt is what? What is the Surjit? Tilt is a distortion. If suppose we are converting the square wave into triangular wave, to complete distortion. Yes, you are understanding. If suppose you are converting the square wave into what? Pulse, that is called tilting. That is extreme case. We don't want to reproduce the signal, we want to differentiate it. When we want to differentiate this signal, means complete distortion of the signal, complete distortion of the signal. I think this is clear to you. Okay. Neha, according to Teja, online examination slot booking dates will be announced shortly. And right. Yes, okay, clear ho gaya point. If you want to reproduce the signal, then RC time constant should be high. If you want to differentiate, it should be low. Next question. Yes, please. Now, for an ideal MOSFET biased in saturation, the magnitude of the small signal current gain for a common drain amplifier. Or a common drain amplifier. What should be the answer? We are having the three configuration in case of MOSFET. This is the symbol for the MOSFET. Everyone please tell me, this MOSFET is P type or N type? P channel or N channel MOSFET? This is the. Tell me. First one, everyone. ये कौन सा है? P channel है, N channel है? First one. Then the second is opposite. Then third and fourth. That is the symbol for. This is the symbol for what? N channel MOSFET. This is the body type, and body is P type, and that's why arrow is inside. Because body is P type, current flows from P to N side, that's why arrow is inside. It is a symmetrical device. We can use the source as a drain, drain as a source. This is the gate terminal. Now this is the body terminal, this is N channel. This is P channel. Again this is N channel. Current from source outside. This is the direction of the current. N channel. This is the P channel. This is the P channel MOSFET. Okay. Right? So 1, 2, 3, 4. Remember this because sometimes they may ask, match the following. Then second question, for an ideal MOSFET biased in saturation, the magnitude of the small signal current gain for common drain amplifier. If you want, what is the gain for common drain amplifier? Remember, for common drain means what? This is the case. Here we are connecting the resistor. Here it is the input, output, Under ideal condition, what is the current? Input current is 0 and we are getting the output current I naught. What will be the gain? I naught upon II. I naught is finite value, II is 0 value. What will be the gain? Under ideal condition, for ideal MOSFET, it is written here. Bias in saturation, the magnitude of the small signal current gain for a common drain amplifier. We are giving the input to the gate. This drain is common. We are taking the output from the source. We are having the current here. I naught upon II, this will become what? Infinite. This will become infinite. Right. ओके चलिए अब देखते हैं जरा एक मिनट के लिए अभी बात करते हैं आप इसका जरा बताना जरा अब अगर आप हाँ दूसरे लॉजिक से अगर जा रहे हैं राइट उसको मैं इस क्वेश्चन के बाद डिस्कस करता हूं ब्रूस वेल ओके जरा बताना जरा इसका भी आंसर बताओ फिर उसके बाद बताता हूं मैं राइट फॉर द n channel MOS transistor shown in the figure for the n channel MOS transistor shown in the figure, the threshold voltage VTH is 0.8 volt. Threshold voltage VTH is 0.8 volt. Neglect the channel length modulation effect. Neglect the channel length modulation effect. When the drain voltage VD is equal to 0.6 volt. When the drain voltage VD is equal to 1.6 volt. The drain current ID was found to be 0.5 milliampere. Drain current ID to be found to be 0.5 milliampere. If VD is adjusted to be 2 volt by the changing the values of R and VDD, the new value of ID is. The new value of ID is. This is the question. For n channel MOS transistor, threshold voltage is 0.8 volt. Write this data here. 0.8 volt. Channel length, neglect the channel length modulation effect means lambda is equal to 0. This is called lambda, channel length modulation parameter. When the drain voltage VD, always remember this is the VD with respect to ground, 1.6 volt. The drain current ID was found to be 0.5 milliampere. This is the 0.5 milliampere. VD is adjusted to be 2 volt by changing the values of R and VDD. R and VDD. Change the value of R and VDD. Simply change the R and simply change the VDD. Okay. The new value of ID is. अब आपने क्या किया VD की वैल्यू को 2 वोल्ट कर दिया यहां पर देखना ये जब when the drain is connected to what gate when the drain is connected to gate it is always in saturation because this is the drain and that is the gate connected and the VDS is nothing but equal to what VGS. VDS is equal to what VGS and in saturation we have the formula half of K and S W by L VGS minus VT the whole square. All these all are constant. VGS minus VT the whole square. This is the case 1. This is the ID1. This is the IGS1. And in first case, what is the current? Current is 0.5 milliampere. And what is the VGS1 or VDS1? Same thing because S is connected to ground. VDS is nothing but VD minus VS and that is equal to what VD? 1.6 volt. So 1.6 minus 0.8 the whole square and you will find the value of K 0.5 divided by 0.8 square. In second case ID2 is equal to same K 0.5 divided by 0.8 square. And what is the value of new value of VGS? Now new value of VGS it is what 2 volt. It will become 2 volt. Write down the 2 minus VT 0.8 the whole square. Get the value. What is the answer? Yes. That is the formula. That is the formula. Simple formula. Right? So you can directly half of K and dash W by L. W by L is called aspect ratio. K and dash is what mu and COX. And you can take all these things as a constant. You can find the value of the K. Right. So you are getting the C answer. A, B, C, D or which one? If suppose I am increasing the value, definitely the value will increase. Definitely the value will increase. Yes, you can check. Oh, you are from electrical branch. To attend regular classes, Ritik. Attend regular classes. We are on YouTube as well as on app, EDC and what analog. Okay. Right. 1.125. Sorry, Akhtar. Okay. Calculate it and you will be able to give the answer for this question. Very simple question. With calculation, please avoid the calculation mistake. And this is a square term. When the drain is connected to gate, always remember that will be in saturation, because in this case it will satisfy the condition that VDS is greater than what? VGS minus VT. Why? Because the VDS is equal to VGS, means definitely VDS is greater than what? VGS minus VT. And that's why when this is connected here, it is always in saturation. Check this value, right? And this is in saturation, not in triode region. Now, what is the answer for this question? An enhancement MOSFET of threshold voltage 3 volt. Threshold voltage is what? 3 volt. Is being used in the sample and hold circuit given below. This is the sample and hold circuit. Here we are using the controlling signal. Controlling signal. Right? This is the VI, this is the V0, this is the C. An enhancement MOSFET of the threshold voltage 3 volt is being used in the sample and hold circuit given below. Assume that the substrate of the MOS device is connected to minus 10 volt. Right? Substrate of that is what? Minus 10 volt. If the input voltage Vi lies between plus minus 10 volt. Input voltage Vi lies between plus minus 10 volt. The minimum and the maximum values of Vg required for the proper sampling and holding respectively are. The minimum and the maximum value of the Vg required for the proper sampling and holding respectively are. Now, in case of sample and hold circuit, in between the switches, in next, this is the switch, right? This MOSFET act as a switch, and for proper sampling, it should be short circuit and it should be open circuit, right? Now, this is the value, and what is the input value here? Threshold voltage is 3 volt. This is the threshold voltage is 3, and what is the, assume that the substrate of the MOS device is connected to what? Minus 10 volt. Again, if the input voltage Vi lies between plus minus 10 volt, maximum value is plus, minimum value is 10 volt. Okay, the minimum and the maximum value of Vg required for the proper sampling and holding respectively are. क्या होना चाहिए भाई? Yes. Jansi, what is this low pass filter, high pass filter? ये कमेंट्स तो बहुत लेट आ रहे हैं, किसका आप लोग जवाब दे रहे हैं? Right. Sorry, time is over now. Just I am giving you the, because it is a 1 hour session only, just I am giving you the 2 assignments. In next session I am going to cover the assignment. Please try to solve these questions. Just I am giving you the hint. Always remember, in sample and hold circuit, right, this will act as a switch. This is called VGS. Once it is connected, then the capacitor will charge, and then capacitor can charge up to what? Maximum value. For example, if it is charged up to what? Maximum 10 volt, and the threshold voltage is 3 volt, right? Threshold voltage is 3 volt. Now you want to switch on the circuit, then what should be the voltage at this point? 10 plus 3, that is the answer. Second thing, and when we want that this switch will be off, then in that case, suppose the capacitor is charged up to what? Suppose the capacitor is charged up to minus 10 volt, because that is the value 10 or minus 10. Let this capacitor is charged up to minimum value of this will try to make this on. What should be the voltage, so that this value should be less than what? Threshold voltage, less than the threshold voltage. Okay, in that case we have to apply a signal so that this capacitor, this circuit will be what? Off. Okay, so that is the logic. Okay, क्या कम्युनिकेशन ड्रॉप कर सकते हैं बार्क के लिए? अब यहां पर पहले 1 मिनट क्वेश्चन थोड़ा सॉल्व कर ले हम लोग. This is the capacitor. It is charged up to -10 volt. Now I want to make this switch off. Let this is the VG. Here minimum 3 volt is required. What should be the voltage at this point? So that this is the VG, this is the VS. So what is the VGS? VG minus VS. That should be less than or equal to what? VT, so that the transistor will be off. So what is the VG? What is the VS? Minus 10 should be less than or equal to VT, 3 volt. So VG plus 10 should be less than or equal to 3. So what is the VG? Should be less than or equal to what? Minus 7 volt. Then the switch will be off. Then the switch will be off. Less than minus 7 volt. Second thing, when this capacitor is charged up to what? Plus 10 volt. And this is the VG. And this is the VGS. And this switch should be on. Then always remember VGS is equal to VG minus VS. It should be greater than or equal, greater than VT. Greater than or equal to VT. So what is the VG? VG is the VG. What is the VS? Minus 10. It should be greater than or equal to 3. Then what should be the VG? It should be greater than or equal to 13 volt. Greater than or equal to 13 volt. Then the switch will be on. Achha, you are Ritik Ranjan. Please send me the number on my Telegram channel. Then definitely they will contact with you. Okay? Don't worry. And they will inform you about all my classes, all the courses available on the BYJU'S platform. Okay? So that is the question. Now last one. 13 and what? 13 is required so that the switch will be on. The minimum and the maximum values of VG required for the proper sampling and holding respectively. Okay? And then second thing, assuming that the transistor, 1 minute, yes, what is the answer for this question? What is the answer for this question? क्या होना चाहिए? In the circuit shown below, all the transistors are N-channel enhancement mode MOSFET. They are identical and are biased to operate in saturation mode. They are identical and biased to operate in saturation mode. Then अच्छा, आप क्या ब्रूसली आप क्या बोल रहे हो? मॉसफेट के हर कॉन्फ़िगरेशन के लिए हाउ कैसे एक्सप्लेन करोगे? इनमें इट मीन्स वी आर गिविंग द इनपुट टू व्हाट? वी आर गिविंग द इनपुट आईडी, राइट? एंड if we are, suppose we are assuming that we are giving the input to what? Gate terminal. So practically in case of gate terminal the input current is what? 0. Okay, input current is what? Ideally the input resistance is what? Infinite, and that's why it is 0. Now from the source to drain the current will be what? ID, and it depends upon the configuration. Normally we are not calculating the current gain in any case. Normally we are not calculating the current gain in any case, but only in what? High frequency analysis. Why we are calculating the current gain in high frequency analysis? Because we are having the effect of what? Capacitor. We are having the effect of what? Capacitor. So I will upload the one PDF related to that on my Telegram channel. Please inform me about that, Bruce Wen. Okay. Now in the circuit shown below, all the transistors are N-channel enhancement mode MOSFET. They are identical and are biased to operate in saturation. This is the question on what? Current mirror circuit. This is the simple question on what? Current mirror circuit. That is the last question. Please give me the answer. They are identical and biased to operate in the saturation mode. Ignoring the channel length modulation, the output voltage V out is. Okay? क्या होना चाहिए? अरे ऋतिक ये तो नहीं अरे चलेगा, लेकिन ऐसा नहीं. कोई देखो भगवान से बड़ा तो कोई है नहीं भाई, हम लोग भी सब इंसान है. बस सिंपली आप by solving the, sometimes we are making the silly mistakes, sometimes we are making some mistakes, yes, every day we are making mistake, right? Every day silly mistakes, sometimes calculation mistakes, right? Sometimes conceptual mistakes, right? But because of practice, we have the command over this subject. Simple thing. From last 20 years, I'm dealing with what? Different subjects like network, analog, digital, and so on, and that is the simple reason we have the command over that subject, nothing else. Okay. Now please tell me, in the circuit shown below, all the transistors are n channel enhancement. Now what is the answer? Option D, Shivjit Mitra, 4 volt. So my dear friends, always remember this portion is what? Current mirror circuit. These two are current mirror circuit. This will make a pair. All the MOSFETs are identical. All the MOSFETs are identical. Means this is the 1 milliampere current. Same current will pass through this, because this voltage VGS1 is exactly equal to what? VGS2. VGS1, let this is the 1, this is the 2, this is the 3, and let this is the 4th one. So VGS1, VGS2 are equal. That's why the current here, it is what? 1 milliampere. What will be the current here? That is the 0. What will be the current here? That is the 0. Now watch this. 1 milliampere current will flow through this. This is the path of 1 milliampere current. What is the current here? 0. What is required here? V out is required here. Now up to this point, what is the voltage? Suppose this is the 6 volt, let this is the 6 volt. Same current, because these two MOSFET, 3rd and 4th are connected in series. So ID3, same current is ID3 here, same current ID3 is here, same current ID3 is here. Because what is the current here? 0. What is the current here? 0. Now the same current will pass from this point to this point, ID3. Now the same current will pass, means these two are connected in series. That's why the voltage at this point, VGS3, is exactly equal to what? VGS2, VGS4. VGS3 and VGS4 are equal. Now we can calculate the VGS4, write down the KVL from this point to this point. When I am writing the KVL, VGS4 is nothing but 6 minus 4 into 1 milliampere. 2 volt. Now this voltage is what? 2 volt. VGS3, VGS4 are equal. This voltage is 2 volt. This voltage is 6 volt. What is the V out? 6 minus 2. 6 minus 2. 6 minus VGS3, that is equal to 6 minus 2, that is equal to what? 4 volt. 4 volt. Okay, that is the question on current mirror circuit, right? So this is all about what second part of analog. If you want some extra topics, then please write me, give me the comments on this channel as well as on my Telegram channel, that we want that this topics, and this is portion from analog, portion from EDC. Now I will take 2 sessions on EDC, part 1 and part 2, and where we will cover what important topic like what? Special diodes, semiconductor physics, okay, and about the MOSFET, MOS capacitor, CV characteristics, right, and characteristics of BJT and characteristics of diodes. Fully focus on what? Electronic devices and circuit. Okay then, thank you for attending the session. For PDF, please join my Telegram channel, right? Simply join my Telegram channel. Now you are on BYJU'S Exam Prep, most comprehensive app for all exams. Thank you very much. Okay.